So question 6, this is part II. You've got to use sine A plus B to show that sine of arc sine 1 over the square root of 5 plus arc sine of 1 over 10 is equal to 1 over the square root of 2. So what you have here, you have one angle between A and A, this angle here between A and B. So just over here on the side, if A is equal to arc sine 1 over the square root of 5, then sine A is equal to 1 over the square root of 5, and by constructing a right angle triangle we can work out that our opposite is 1 and our hypotenuse is the square root of 5, which would mean our adjacent side, that's our A, our adjacent side has to be 2 using Pythagoras' theorem. 2 squared is 4 and 1 is 5, so that there the hypotenuse has to be square root of 5. So if that's our sine A, we can also say that our cos A is equal to adjacent over hypotenuse, that's 2 over the square root of 5. And you repeat the process for your B. So B is an angle which is equal to the arc sine of 1 over the square root of 10, which means sine B is equal to 1 over the square root of 10, and that allows you to construct a right angle triangle where B is your angle. Your opposite side is going to be the 1, because the sine is opposite over hypotenuse, so that means your side there is going to be the square root of 10. And using again Pythagoras, you can work out that this here has to be 3. 3 squared is 9 plus 1 is 10, which would be equal to the square root of the hypotenuse. So once you have that there, you can work out what cos B is. Cos B is the adjacent over the hypotenuse, that's 3 over the square root of 10. So there's your sine A, your cos A, your sine B, and your cos B. Go to your log tables and look for sine A plus B, and see that sine A plus B is sine A cos B plus cos A sine B. So sine A plus B is the same as right there. Sine A plus B is equal to sine A cos B plus cos A sine B. So there's the second one on the left, page 14. And you know what sine A is, you know what cos B is, cos A is, and sine B is, because you've got them all worked out here. So you're just substituting in. Your first one is sine A, that's 1 over the square root of 5. Your second one is cos B, that's 3 over the square root of 10. And over here you have cos A, which is 2 over the square root of 5. Then you've got sine B. Sine B is 1 over the square root of 10. So the square root of 5 or the square root of 10 is the square root of 50. And you've got 1 by 3 is 3. And square root of 5 and square root of 10 again is the square root of 50. So then you've got 1 by 2 is 2. So you get 3 over the square root of 50 plus 2 over the square root of 50, which is 5 over the square root of 50. Now you're trying to get it to look like this, so you factor out the square root of 25 by the square root of 2 at the bottom, that's what the square root of 50 is. And the square root of 25 is really 5. So you have 5 over 5 the square root of 2, and they cancel to leave you with 1 over the square root of 2.